All right. Thanks for joining us today, Matteo.
Hey, great to be here, Brian. Thank you.
Yeah, so we're talking about a subject that I find really interesting, which is actually real soft start technology, not stuff that people call soft start. And so Matteo reached out, and I've been kind of following Micro Air for a while, and so this is going to be pretty cool. To start with, though, Matteo, if you wouldn't mind, just introduce yourself a little bit, kind of your background and what you do.
Absolutely. I am an electrical engineer, and I have been for over 35 years now. I started off working I've always been in product development, started off working in the Northeast for the old Digital Equipment Corporation, making hard disk drives, believe it or not, back in the day when the biggest one we were making was only 4 GB. So now you really know how old I am. And time went on. I eventually ended up moving to Florida, which is where I am now. And I have worked the past 20 years plus years in the marine air conditioning industry and now in the residential air conditioning industry. I worked for Dometic Corporation, the manufacturer of the cruise air and marine air conditioners, who those of your listeners who own boats will know exactly what I'm talking about since they pretty much own the world market. And I was working in the engineering department, and we were manufacturing hundreds of air conditioners a day. So through osmosis, I learned a lot about air conditioning, and now I actually have all my own equipment and go out on the weekends and do service calls for people like your techs do. And so I have a real good hands-on appreciation for your audience and what they do all day, every day. So anyhow, the Microair, the company that I now consult for, I became a direct employee of in 2012, and that was when we developed the Easy Start. Microair still is the strategic supplier to the marine air conditioning industry in that they make all of the thermostat controls. So Microair has a big tie to air conditioning in general. And Easy Start, the soft starter, was initially developed for marine and now has migrated into the much larger markets of RV and home, and that's really where it found its fame. So I was one of the original development engineers for Easy Start when it started, and now I am, in a consulting capacity, the sole continuation engineer. I did all of the most recent developments and all of the changes, including the Bluetooth hardware and firmware and apps that were introduced in 2019. So the buck stops with me when it comes to this product.
Awesome, yeah. And I know techs always get scared when they hear engineer, but hey, Matteo can use tools too, so it's
Oh
good to
yeah,
hear.
I'm one of the most hands-on engineers you'll find. Like I said, I have all my own stuff. I can braze fairly well. I have all, torches, vacuum pumps, recovery pumps. I just was buying Freon last week because I ran out, and I have accounts at all the local supply houses. So I hope that your audience can appreciate my connection to what they have to do all day, every day.
All right, so let's jump into the Microair Easy Start. Let's talk a little bit about that product, what it is, and what it does.
All right, so the Microair Easy Start is a soft starter, not a hard starter, which we will talk about later because we do a little contrast because that's one of the very common questions. So what is a soft starter? A soft starter is a device that has been around in the commercial industry for decades. And what it does is it electronically ramps up the voltage and the current to the compressor motor or any single phase or three-phase motor for that matter, to gently ramp it up as opposed to abruptly attempting to start it with all of the force behind all of the power from the utility or from whatever source it is. So a soft starter is kind of the opposite of a hard starter. It is a gentle ramp of the compressor motor in order to eliminate that very large spike that occurs whenever a compressor motor or any motor starts up, the so-called lock rotor amperage, which I'm sure your audience is very familiar with. So the Easy Start accomplishes this through all of its very sophisticated electronics. It has semiconductor devices that it uses to throttle the voltage and the current to the run winding and the start winding separately, in order to accomplish this, and we'll get into that more later on. Easy Start was, of course, designed for air conditioning compressors, but it also has been applied to other motors. Easy Start is only for single-phase motors. Microair does not manufacture a three-phase version, although they do exist in the market. The single-phase application, of course, is much more prevalent, especially in the home air conditioning market and the marine and RV markets. So that's where Easy Start was focused. So the models that exist for the Easy Start are as follows. There are basically two. The first model, 364, is the small model that has found great favor and huge popularity to the tune of upwards to 70,000 units now in the field in primarily the RV air conditioning market. This model can support up to 2.5 tons. There is a 120 volt only version for the RV customers, and then there's the 240 volt 50, 60 hertz version for obviously for residential and commercial applications up to 2.5 ton. The enclosures for Easy Start, just to note, and we can talk about this a little more later, are weatherproof, IP65. The good thing about that is when you install it, you may not always have room in the electric box to fit it. So if you have to put it on the outside of the unit, exposed to the weather and the sunlight, it'll be fine. It also has UV resistant plastic as well. The Model 368 is the larger model that does, there are two sizes, one for 3 and 4 ton, and then one for 4.5 ton, all the way up to 6 ton, which is the largest single phase compressor that's available on the market. Typically the largest one that your listeners would run into would be a 5 ton, but I have installed an Easy Start on a 6 ton pool heater condensing unit at one point with a massive 180 amp lock rotor, and it's still working to this day. So Easy Start 368 can handle units up to that size.
And worth noting, because we do a lot of pool heating equipment in my business, and I like to talk about pool heating a lot. It was actually one of the things early on that we did to sort of fill in the winter. And those are some of the worst lock rotor components that you've got, because like you mentioned, they're huge compressors.
Unbelievable.
Yeah, and so having something that's going to help, even for just things as simple as dimming lights and that kind of thing, but also just for the longevity of the equipment, it makes a big difference. And we'll talk about that, obviously.
Yes, absolutely. And in fact, we'll get into that right now. The customer for which I put the Easy Start on for the pool heater did want to be able to run on generator in the event a hurricane came and took out his power. So I guess he really wanted to enjoy his pool under those conditions. But in any event, here are the main benefits, two of which you've already touched on, two very important ones. The primary benefit of Easy Start is to eliminate that inrush and that locked rotor surge, so that now your air conditioner, which would not have been able to start up on a limited power source like a generator or a solar inverter on a home, can now succeed in doing so. The best example I can give is back at the RV application. A lot of RVers, most RV air conditioners are no bigger than 15,000 BTUs. A lot of RVers love to carry that little Honda EU2000, now EU2200 red portable generator. That generator has enough to run that those RV air conditioners, but not enough to start it. So enter Easy Start, and it now took a situation that didn't work and makes it work very reliably. And that's that you can size up to a home application, where now you're dealing with a standby generator on a house that's not quite big enough to start the air conditioner. Add Easy Start, and now you can. We have several solar contract companies that install Easy Starts routinely on every air conditioner on the home whenever they do their solar installations and their battery backup systems, be them from Tesla or from other brands that have battery systems with inverters for home. So that's the big benefit right there. Now, the other thing that you can do is, if you don't have a generator, you mentioned it, on utility power, sometimes that can be a problem, especially if the utility power is limited or there's dilapidated electrical wiring. things of that sort. This happens a lot in the marine industry on old boating docks where the wire at the end of the dock is 100 feet long and rusted out, or in the RV in the parks, it's the same issue. Homes have that to a less degree, but it's still there. Now with Easy Start, that surge that occurred when the compressor starts no longer causes the lights to dim or the UPSs for your computers to start beeping or other electronics in the home to be affected, because that surge and now that huge current demand is gone, which would have caused a momentary drop in voltage. So if you do have a situation where you've got a generator that, let's say, that's already large enough to start your air conditioner, adding Easy Start can help you there as well, because now you won't have to power manage quite as strictly when you're operating off grid. So you can have more appliances in the house running, and so when your air conditioner goes to start up, which you typically don't have control over directly, you just let your thermostat cycle it as needed. Now you won't have to worry so much about making sure everything else is off when your air conditioner goes to start. So there's a benefit for homeowners as well who might already have a large enough generator. And then last but not least, the other benefit you mentioned on utility power, which is where you're going to be 95% of the time, just the simple act of soft starting a compressor will most certainly extend the life of that compressor. The mechanical and the electrical stress endured by a compressor motor when you're hard starting it repeatedly day in and day out definitely deteriorates the windings and the motor and the compressor mechanics. Soft starting, of course, pretty much eliminates that stress, and so now you can expect a compressor to live a whole lot longer and give a much more effective life for as long as the unit is in use. So that's a great benefit there.
It's such a mindset shift, and this is the big thing that I want to talk about in terms of what we think we're doing in order to help a compressor. So many people have been selling hard start kits, or what they would call soft starts, which is really just when a lot of people say soft start, they just mean a really crappy hard start. They've been selling these for years and calling them compressor savers of some sort. And they always had this thought, well, the goal is to get the compressor running as fast as possible, right? It's the exact opposite of what we're saying here, but that's because we couldn't throttle the current and the voltage, and especially we couldn't throttle the current and the voltage to both windings. I talk about this all the time, where we get so confused about what we're doing with the start winding. We're always focusing on the start winding with hard starts, but really the run winding is where the majority of the current is taking place in a typical single-phase piece of equipment, because of the fact that you have this run capacitor, which is greatly throttling the amount of current that the start winding can see. And the only thing that we're doing with a hard start is just pumping up that current that start winding is seeing.
Absolutely, and I watched your start cap video, and that's obviously, as you know, what put me in touch with you. I was so impressed because I have had to explain that 1,000 times, obviously, because people don't understand the difference between hard start and soft start, and it is exactly the opposite. A picture is worth 1,000 words. So for those of your viewers who are watching on YouTube, here's a graph that really captures it all. You can see how the hard start is a very abrupt, high peak that lasts maybe 200 milliseconds and goes all the way up to, like, say, 80 amps for a 3-ton home unit. Whereas with Easy Start, now the startup is this gradual ramp that lasts about 600 to 800 milliseconds and tops out in the 25 amp range. Big difference. Obviously, now we're definitely changing how the motor is accelerating and dramatically reducing the current required in order to accelerate. And that's the whole magic of the electronics in Easy Start. It is, in a closed loop fashion, it is ramping up the run winding and the start winding in order to accomplish this gentle acceleration without overdriving it and causing unnecessary current and unnecessary inrush. So that's really the big benefit there. And if we go and look at a couple oscilloscope waveforms to go along with that graph, for those of your viewers on YouTube, you can see on the left what a conventional hard start looks like where there's a big high amplitude current spike, sinusoidal current spike that is blown up on the scope shot in that box that's highlighting it, and then the blow up is on the bottom. Whereas on the right, you see what the easy start ramp looks like. And in this particular case, this was an RV unit that went from 51 amps down to about 13 amps peak, which was quite tremendous. So it's like night and day.
Yeah, and the thing I want to mention again, and you can always correct me when I'm wrong, because I'm sure I am at times, and you know a lot more about this than I do, but the thing that so many technicians have been doing for all these years, when they take their meter and they put it on inrush mode or whatever, and they measure, and they're like, well, this one's higher than that one, and they get really confused, because what I think a lot of people fail to, or a lot of them fail to understand, is that inrush current is really dictated by the resistance of that winding when the motor is stopped. And that resistance of that winding when the motor is stopped is fixed, just the truly resistive feature of that motor, versus what happens when that motor starts to spin. That's when you begin to generate back EMF, and that's when you begin to get that inductive reactance that opposes and allows the current to drop. That current drops as that motor spins up to speed. And so unless you are actually throttling the current, throttling the voltage in an active way, the only option you've got in order to reduce the time averaged current is just to make it start faster. But when you start faster, you're actually increasing the overall current. You're actually, that kind of instantaneous current is increasing because you are shifting more current to that start winding, which in turn is just a more violent thing. And when a motor is designed for it, the compressor manufacturer says, hey, here's the start capacitor that's for it and all that. It's okay, but then we know things happen. Like, we know potential relays fail. They fail stuck, and now start windings fail. We know that it is a more abrupt and violent motion on the compressor itself, meaning the mechanical parts of the compressor. And so for all of these reasons, there's really no disadvantage that I can think of, and you can tell me if I'm missing something here, but no disadvantage to actively managing that voltage and current, so that way you don't have this gigantic, spike. It is just a much slower start. And when we normally think of a slower start, we're like, well, that's bad, because a slower start would mean that it's drawing higher current. But that's why this is a whole different paradigm, because we're actually actively managing those things.
Yes. You're absolutely right, and I want to jump ahead to that start cap heart start comparison too, because I made a nice drawing for you that I think you'll like, and your viewers will appreciate, along the lines of what you just described. But just to hit on that one point you just made, when the Easy Start orchestrates this ramp, it does so in a very, very sophisticated way. Easy Start's, just to dig into the technical part of it for a brief moment without giving away any too serious proprietary information, Easy Start is monitoring in real time both the voltage and the current that the compressor run winding is drawing, and the start winding as well. And when it goes to initiate the start, it also can detect the compressor's rotation. And we do that by monitoring the phase of the start winding with respect to the run winding. And you talked about that a little bit in your start cap talk, and we'll get into it a little bit more. Capacitors shift the phase of the current by 90 degrees. However, when the motor is stationary, that phase shift is nearly zero, because initially everything's a resistor. But once the back EMF and the inductance of the motor and the effect of the capacitor, be it a run or a start capacitor, comes into play, now the current that's going into the start winding shifts out of phase with that of the run winding, and that phase shift increases as the motor speeds up. So Easy Start can detect that, and we monitor it and collect it real time in order to orchestrate this ramp. So Easy Start applies some voltage and some current, waits for the compressor to budge, applies a little bit more, waits for it to accelerate more, applies more and more and more, and then orchestrates this whole ramp in real time in order to get it to full speed, which is a far cry from what happens under the normal OEM configuration or with a hard start. So it is truly a very sophisticated device, and that's how it orchestrates the start in order to attain these 65 to 75% start surge reduction on average, which is quite impressive.
And we know that slow ramp is not a problem. We've all gotten comfortable with that because we have all these inverter-driven systems now that essentially do the same thing.
Correct.
Do it in a different way because now you're using, essentially a three-phase motor and you're just changing the frequency. But we know that that's a good thing. We've experienced that. So there's nothing wrong with taking a motor and starting it slowly. We just don't want it to stay locked. So by utilizing the circuitry, you're actually able to, like you said, say, okay, now we're just going to slowly, we're looking at that feedback from the motor, and we're going to slowly increase it until it gets up to its full speed as smoothly as it possibly can.
You're absolutely right, and I think the common misconception came from the fact that people were worried that with a start capacitor or a hard start, which is basically a start capacitor and a switching device in series. People were worried that if you slowed down that condition, you would be overdriving the start winding for too long, which, as you just mentioned, if the start relay welds shut or something else bad happens, you will in fact do that. You will in fact overdrive the start winding. And that's where I think the misconception came from, that doing the start for too long is potentially hazardous to the compressor. Not with the case, that is definitely not the case with the Easy Start and a soft starter in general. We're doing the exact opposite. Yes, we're extending the time at which it takes to accelerate this compressor, but we're not dumping all of the voltage and all of the current onto the run winding and the start winding at once. We're gently applying it. So extending that time actually reduces the total amount of energy that you would have applied to the compressor over the course of that start. I do get a lot of questions that people ask about, will Easy Start save them on their electric bill? And the answer is no. Although it does reduce the amount of energy that the compressor consumes over the course of that starting episode, it's such a short duration of time, right? Less than a second, that the kilowatt hours that you would save would add up to less than a penny over the whole course of your month-long bill. But the point, once again, is we're by extending the time, we are not applying more unnecessary energy to the windings. It's actually the opposite. We're applying slightly less overall energy to the windings, spread out over a greater period of time, which in fact is better for the compressor, right? Less resistive heating, less stress on the windings of dumping all of this lock rotor amperage versus doing the opposite. So taking your time starting the compressor is not a problem with Easy Start.
Awesome. Yeah. So let's talk through, I'll kind of let you talk through some of the specific differences between hard starts, wiring, and kind of going into the Easy Start, some more of those specific details.
Yes. And I got some pictures here. I like to say that hard starts versus Easy Start is apples and oranges, and they really are. And you already touched on a couple of these things, but a hard start is simply a start capacitor in series with a start relay, a solid state device, switch like a triac or a PTCR, a resistor, and we'll talk about that a little bit in the next slide. So a hard start does in fact increase, very briefly, the startup amperage by funneling more current to the start winding. But by doing that, it increases the torque on the compressor and therefore increases the acceleration speed, thereby reducing the overall startup time or duration. Hard starts were traditionally developed to help old, tired compressors start, and you alluded to that earlier. And that's really what they were there for. Most of the time when people have a off-the-shelf, commercially available clamp-on ammeter, the installation of a hard start, that momentary increase in startup current that the hard start causes cannot be captured by those off-the-shelf clamp-on ammeter devices, except for maybe some real good ones that became available over the past few years. In a lot of the videos that I did for Microware, I had developed my own homegrown peak current ammeter that you'll see in the videos that captures that peak much better, and you can clearly see how the hard start increases the amperage versus having no hard start at all. Brian, this is the slide that I specially prepared for you to supplement your soft start or your hard start capacitor description back when you did that presentation a few months ago. So here you can see how the wiring is done for the run capacitor, which is shown at the very top of this little array of devices that I have here. And a lot of times you'll find that most home systems don't even have start capacitors in them, as you mentioned earlier. Some manufacturers just choose not to add one since it really provides no benefit. But when they do, they have a few choices as to what they can do, and a lot of the wiring diagrams for home units will show dotted lines for where a start capacitor and a start relay or some other solution, hard start solution, is optionally installed or not. So the first one, of course, is a start capacitor in series with a start relay or a solid-state switching device. And as you can see here, what happens during the start is the start capacitor and the run capacitor go in parallel. And when you parallel capacitors, those who had basic electronic training know that capacitors add when they are placed in parallel, similar to how resistors add when they are placed in series. So with a larger capacitor between the run winding and the start winding, more current gets passed to the start winding during the brief starting instant. Capacitors, I like to refer to them as AC resistors. You used the balloon analogy, which I liked in your video, where you talked about how energy builds up on one side of the capacitor and passes through to the other side. In the end, that boils down to a term known as impedance, and impedance is actually AC resistance if you think about it in simple terms. So by adding an additional capacitor to the run capacitor, you reduce the impedance between the run and the start winding during the startup only, and then that's what funnels more current to the start winding. Obviously, once the start is done, you have to open up that relay or turn off that solid-state device. Otherwise, the start capacitor will overheat and will eventually fail. And that is the fear everyone is most concerned about when starts take too long. So that's a start capacitor with a switching device. The other solution that some manufacturers have implemented is using what's called a PTCR in series with a start capacitor. A PTCR, that stands for positive temperature coefficient resistor. It's basically a resettable fuse. And what it is when current will pass through it initially, and its resistance will be very low, down in the tens of ohms. And then as it heats up, as current flows, its resistance climbs to basically almost an open circuit. So like a resettable fuse, it will eventually open up. So that's another alternative way to connect a start capacitor momentarily during the startup. And then last but not least, some manufacturers choose to just put a PTCR across the run capacitor, which the PTCR behaves in the same way, but there's one critical key difference between a PTCR alone and a PTCR with a start capacitor. And I'm going to ask you, Brian, since you're a smart guy, to answer that. What is that difference?
Yeah, so when you're using a PTCR alone, you're passing current that isn't phase shifted.
Correct.
So it's
exactly.
just you're just directly passing across the line, basically.
Very good. I knew you would get that right. PTCRs are, when the motor is stationary, the fact that the phase of the current applied to the start winding is not shifted, it really doesn't matter. It's only once the motor gets rotated that phase shift really starts to matter. And so a PTCR alone may help budge the compressor initially, but it won't do a very good job of assisting the compressor as it's accelerating, and in fact could hurt you, because now it might actually oppose what the run winding is doing as opposed to assist it. So that's an important point there.
Yeah, and let me just add,
Sure.
when you think about a PTCR, it's a really sloppy hammer, to get the thing started. It's not,
Yes.
It doesn't reset quickly. Which is another thing. It has to cool down.
Down.
PTCRs, in my opinion, are just they were really only used because, at least from my way of thinking, there may be other reasons, but because they were cheap. When you thought of the old, Carrier used to have a version of a PTCR start, and we actually would call it a soft start. That was the term that was used. And I think even when you looked at the part, I think it actually said soft start, but it's this little blue PTCR. The things would fail all the time, and you would actually go into cases where you would have these things failed, and they would essentially be shorted, and it could actually even cause damage to the equipment.
The start winding, and then you'd
exactly.
end up having to change the compressor because the start winding got burned out.
Yeah, and another thing I want to mention here is, typically we're not using a lot of those. There are some brands that still do use PTCRs and some that use them in conjunction with a start cap. Those are out there, but even when you get into your typical potential relay, you mentioned that if you have a potential relay that sticks, so the actual relay contacts stay stuck, then that can result in start capacitor failure, which is absolutely true because a start capacitor is not an oil fill, doesn't have that oil fill design, so it doesn't handle the heat. And so when you see them kind of explode on you, that's a big cause. But also during that period before that thing fails, that start winding on your compressor is taking a big hit. And it really is, it's a bad thing. But then also the other thing we talk about all the time that is the scariest thing about your typical hard start kit is that if the hard start kit is not failed, but the run capacitor fails, now you're relying on just the hard start kit, and you can potentially still start the compressor, where normally when you have a run capacitor fail, that compressor's not even going to start. Now you could get the compressor started, but now once it is started and it drops out, now that compressor's really going to struggle to stay running and is going to run really hot. And we'll probably go ahead and ramp back down, install, and eventually go out on thermal, but it could do that a really long time before you catch it, potentially resulting in compressor failure.
Yes, absolutely. There are a lot of hazards with hard starts that people don't realize, and over the years, manufacturers, in general, I agree. I don't see the PTCRs at all anymore, and in very rare cases do I see even a OEM installed hard start potential relay with a start cap. I rarely see those now too. They just go without because most of the compressors seem to start reasonably well without them, and so they don't need to even bother.
I do want to kind of bring up your point that you brought up about the old compressor that really is having a hard time starting, because that is a case where I probably still would use a hard start, because that isn't the role of a soft start. The soft start, at least to my understanding, isn't going to help in those sorts of circumstances, and that isn't the design.
Very, very good point. Yes, a hard start is appropriate when the compressor is old, and let's say you're not attempting to run it on a limited power source like a generator or a inverter. All the more reason. You're basically trying to extend the life of the compressor before you're forced to replace it. Give it a little extra at the end of its life. So that's all that the hard start is really. Those were what they were really originally developed for, and there's still many times where it's appropriate to do that. So I totally agree. So let's take this same drawing and just cut out the hard starts, and let me show you in one picture, and this will be, and I can talk to these connections as well, how the Easy Start wires in. And that is basically the first thing you have to do when you go to install the Easy Start is remove any of those hard starts. So there's an aftermarket one installed, or the original equipment manufacturer installed one as part of its design. You take that out, or at least disconnect it, and make sure it's no longer affecting. So in the end, you end up just with the run capacitor. At that point, you've got 4 wires on the Easy Start, a black and a white, which are L1 and L2, which go straight to the contactor output. So that's easy. So you're halfway done. And then the third wire splices directly to the run winding. Now, most of the time, the run winding, let's say it's a red wire, which is very oftentimes used, is connected to the output, the L2 output terminal of the contactor, which is sometimes labeled T2 or T3, depending on the contactor manufacturer. You're going to disconnect the run winding from the contactor so that now the run winding is floating in free space. And in its place is where you'll put the Easy Start's white wire, exactly. But now the run winding connection floating in free space needs to get spliced to the brown wire from the Easy Start, as shown in this diagram here. And so that's your third connection. And last but not least, the orange wire from the Easy Start goes to the terminal of the run capacitor that ultimately connects to the compressor start winding. That terminal is typically labeled HERM for hermetic on the run capacitor. So even if it is a dual run capacitor, be careful not to put the Easy Start's orange wire on the fan's start winding. Make sure you put it on the compressor's run winding, and you're done. So at that point, your wiring is all set. So Easy Start goes in very easily. Probably the biggest challenge is figuring out where to put it. Most cases it will fit inside of an electric box for a decent sized unit, but if not, we talked about it earlier, you can mount it on the outside of the unit on the cover of the electric box, since it is IP65 and UV resistant plastic, so it can get exposed to the elements without any problem.
Yeah, and so one thing that I just immediately becomes evident when you see how it's wired is that the Easy Start is controlling the run winding.
Yes, totally controlling it.
And there's nothing else in the market that does that. Because because that's where everybody gets their heads all confused, because they think that inrush current occurs on the start winding because that's the name of it, right? They think, well, it's the start winding. That's where all the start is, but that's not the case. And in fact, the easiest way to prove that is just disconnect your start winding, disconnect your run capacitor, and then check your current on common, try to start that compressor and see what the current is. And of course, it's going to be astronomically high. That inrush current under normal operating conditions is primarily in that run winding. When you add a hard start kit, well, that also now adds additional current to the start winding as well, increasing your peak. But in this case, we're really controlling both. We're taking control, but really a huge part of it is taking control completely of that run winding, which is what gives it kind of this superpower.
Exactly. No, I'm glad you pointed that out. And quick story, I actually have tried to start an Emerson scroll compressor without its run capacitor, and it worked. Some of the smaller ones will actually go without a start. They run terribly, of course, because they're not going to go for very long, but the bulk of the starting current is through the run winding, as you just said. And if you think about it, what are your typical run and start winding resistances? 2, 3 ohms, something along those lines? Well, guess what? A run capacitor that's, say, 40 microfarads is on the order of, like 50 ohms of impedance or something like that. And that, of course, now you're saying, oh, I've got a 2 ohm path and I've got a 52 ohm path. Which one am I going to take? The bulk of the current is obviously, it takes both, but it's parallel resistors, right? The bulk of the current goes to that run winding during a hard start.
Yeah, and all you have to do is just take a current reading on your start winding sometime when the system's running. This is what blows my mind. Nobody ever does this, but just do it. See what it is.
It's very low.
And then take a current reading when it starts. So put it on your inrush setting on your nice expensive meter and put that on your start winding and just see what it does. And what you'll notice is there is no inrush on the start winding. If you don't have a hard start kit, the inrush is all on that run winding. And that's why something like Easy Start, it has to take control of the run winding in order to control inrush, in order to keep that initial torque low, and in order to ramp it slowly.
Exactly. In the installation video I did, you can actually see in the brief delay that Easy Start imparts before it actually ramps the run winding, you can see the amount of current flowing through the start winding, because obviously that run cap stays in circuit even with Easy Starts not orchestrating the start. And it's only about 2.5 amps on the 3-ton home unit that I demonstrated. Obviously, once things get going, then the bulk of the current that is required to start, upwards to 25 to 30 amps, went through the run winding. So yeah, it's not common knowledge that of what you just said, the start winding takes very little current compared to the run winding. All right, moving on. Just a couple things about Easy Start that I want to point out, and then I want to talk about some of the protection features to kind of dovetail into what we just talked about, how bad things can happen when hard starts fail. Easy Start is actually quite the opposite. You're going to be way better protected. So we'll talk about that in a minute. But After you install the Easy Start, just a couple quick installation notes here once you've mounted it and all the wiring is done. Easy Start is so smart that it actually takes the first 5 starts that it orchestrates on your compressor, and it records the information internally to learn the compressor. And as part of those 5 learning trials, as we like to call them, Easy Start will optimize itself to bring that starting current to the absolute minimum achievable for that given compressor. So what does this matter to you or your installer or a technician who's installing one of these? It really doesn't if the customer is operating on utility power and all is well. You can just let the thermostat cycle the Easy Start in the system normally, and the 5 learning starts will happen automatically. However, if the customer is chomping at the bit to try and run their compressor or their air conditioner off of their generator, we recommend that you allow the 5 learning starts to complete on utility power before you start switching back and forth between generator power and utility power and inverter power. The reason for that is Easy Start, think of this as a real strict engineering type testing and evaluation. You want minimal conditions to change from learning start 1 to learning start 2, learning start 3. That is, you want your power to remain fixed. And that isn't always the case with a generator. So the learning and the hair splitting that might go on during the learning process happens more precisely and more accurately if you allow those 5 starts to occur on utility power. Once the learning is done, it's done forever, unless you reinitiate the learning, which we'll talk about later, if you moved Easy Start to, say, a different compressor. But once it's done forever, and after that you can switch back and forth between utility power and generator power as often as you like. There's no limit there. So another little tidbit, the Easy Start is smarter than you think it might be. I want to talk about the fault conditions though now, because that I think is probably the most important feature of Easy Start above and beyond the reduction of starting amps that we've talked about here extensively now. Once Easy Start is done ramp starting the compressor and it bypasses itself internally with a relay, so all of the solid state electronics are switched out, it stays alive, of course, and it continually monitors the compressor for some pretty nasty things that can cause you harm. Specifically, a stall condition. Let's say voltage dips and the compressor stalls. Well, once the compressor stalls, you really don't want to try to restart it once the voltage is restored. You want to quit. So Easy Start, using that phase detection that it has, it knows when the rotor is stopped rotating, immediately disconnects the compressor, waits 3 minutes, and then reorchestrates the soft start again. So that happens in the case of a stall. And that response is pretty much the same for all of the fault conditions. Similarly, overcurrent. During the 5 learning starts, Easy Start averages over the course of 5 minutes the current that the compressor is drawing, and it saves that away. So Easy Start knows roughly what your compressor is drawing while it's up and running, in addition to what it does during starting. So Easy Start kind of tailors its overcurrent detection based upon what your compressor is doing under what we'll call a normal condition. So if it ever were to exceed that by like more than a factor of 2, Easy Start will say, hey, something's wrong, your condenser fan has failed, or the leaves are blocking the condenser's really dirty and it's running really hot and the current has shot way up. Easy Start will shut down the compressor, wait 3 minutes, and restart. An overcurrent fault, like a stall fault, is automatically recoverable, so it'll do that. But the beauty is now you're not going to leave the compressor running for an indefinite period of time until its thermal overload opens. Easy Start will actually protect the compressor better. Similarly, if the thermal overload does happen to open, Easy Start will detect that, because obviously when the overload cools off, the Clixon device cools off and recloses, you don't want a hard start to occur, you want a soft start to occur. So Easy Start will detect when the Clixon recloses and wait and initiate a soft start again. Additionally, because Easy Start is looking at the start winding and the run winding to detect phase, it can also tell when somebody hasn't wired it right or if a wire were to fall off. So Easy Start does have a wiring fault that is permanent. So if you ever did install the Easy Start and you did it wrong and it doesn't work, chances are you wired it wrong and Easy Start has a fault condition it's displaying. And then last but not least, and this is the one I like the most as far as Easy Start's compressor protection feature, and the one I probably spent the most time on since I don't like waiting, and you'll know why in a moment. Easy Start can detect a very, very narrow power interruption or brownout. And as you probably know, compressors don't coast. When you remove power from a compressor, it will come to a screeching halt, and typically in less than 50 milliseconds, or 1/20th of a second. Easy Start detects that. And if power blinks off and blinks right back on again, sometimes the thermostat or the compressor's, the air conditioner's electronics misses that and would ride right through. And under normal conditions, that compressor is just going to try to restart again. Well, as we all know, the worst thing to do to a compressor is be running it, shut it off, and immediately try to restart it. Why? All the internal refrigerant pressures have not had time to equalize at all. So your discharge pressure is up high and your suction's down low, and now you're going to ask the compressor to start against that huge head pressure. Ain't going to happen. So Easy Start detects the very brief power interruption that could cause a stall and waits 3 minutes and then reinitiates the soft start. And people know probably, and I've seen them installed on many home units, what's called a delay on make timer or a delay on break timer that are very commonly applied into the thermostat 24 volt circuit to delay the closure of the compressor's contactor when the thermostat calls for it to run. Sometimes these get added. I really don't know the purpose of that other than the fact that the thermostat may be dumb and may not have its own delay built in. But I've seen it done even with sophisticated thermostats, so it's really unnecessary. But for whatever reason, Easy Start's short cycle prevention timer that I've mentioned as being 3 minutes is smart in that if Easy Start had been off for 3 or more minutes, the next time Easy Start gets energized, it will not delay any additional time. The minimum delay Easy Start always imparts is 5 seconds, and the maximum delay is 3 minutes. So if the compressor had been off for say 2 minutes, and Easy Start was energized again to ask the compressor to run, Easy Start will wait only 1 additional minute. And similarly, if the compressor had been off for 10 minutes, and Easy Start was energized again to start the compressor, Easy Start will only wait 5 seconds. So we made a special circuit in Easy Start because I hate waiting unnecessarily, and that's what we like to call the smart short cycle prevention timer. And so as you can see from this list, Easy Start is really, really watching out for the health of the compressor. And this is above and beyond what its primary purpose is. So no doubt, Easy Start will protect your compressor better than the OEM configuration and will extend its life.
Yeah, I mean, we see this specifically with certain scroll compressors. I won't throw any brands under the bus, although I did recently, accidentally on a video. Certain scroll compressors, when you do that kind of instantaneous kind of shock, and we see it a lot when somebody's cleaning a drain and they jiggle the float switch, or they bump, they go to check it. They go to check the float switch, they pull it out, it bumps, and now next thing you know, the unit's running.
I've done that.
But it's not pumping, and what actually happens with some of these compressors is they'll actually run backwards. When that instantaneous thing happens, I mean, they shouldn't. I don't know why that is allowed to happen with this particular brand, but we've seen it, hundreds of times at this point. Where those compressors will run backwards, which is awful for them because they'll just keep running backwards until it cycles off and cycles back on. So,
and it may never cycle off because it's never going to cool under those conditions. So
exactly.
Terrible.
So, and that can happen. A customer could do it. A customer could go check their float switch and it runs backwards. So this would prevent that type of thing from happening.
Oh yeah, totally. And it's quite huge. I mean, especially in utility environments that are poor, like. This is why RVers and marine applications love it because there the power is typically of much poorer quality, and the power wiring is, of course, often questionable, and so this is a great benefit. It certainly protects the compressor when it otherwise wouldn't. And there are actually a lot of old style mechanical control air conditioners out there that have no built-in short cycle delay. So Easy Start would be their only line of protection if somebody turned it off at the knob and turned it right back on again. So it's quite a big gain from that.
Yeah, for sure. No, I like it.
As far as the description of Easy Start, that pretty much covers it. And I'd like to talk about a couple additional features that are kind of new over the past couple years that I think the techs will really enjoy. Gadgets are important, so people are loving the fact that they can have their home thermostat on Wi-Fi and they can see what their house is doing while they're at work or something like that, or while they're away. Because Easy Start, well, let me back up. You'd be shocked as to the number of people who have installed Easy Start on their own in the RV world. The RV world is made up of a lot of do-it-yourselfers, as is the home market too in a lot of cases. But we've had a lot of people install Easy Starts on their own because it's really fairly straightforward if you can read a wiring diagram and it's 4 wires. But a lot of times when we ran into problems under those particular situations, we really had no recourse to help these people because we couldn't put eyes on what was going on. And customers, if they weren't within reach, driving distance of, say, me in Florida or one of the team members at the factory in New Jersey, we couldn't really do anything to help them. The next thing you know, they'd be maybe taking photos or shipping the unit back again and find nothing wrong, and it's all a bunch of wasted time. So 3 years ago, the owner and I got together and we said, you know what, we really need to put Bluetooth on Easy Start because this will allow us to upload data and do a whole bunch of other things that we couldn't otherwise not do, and it really would advance the application of the product. And let me say this, it's been huge. Easy Start is very popular now, and there is no way that the support team, it's really only 3 or 4 guys in New Jersey, could handle the load if it weren't for the Bluetooth. The Bluetooth feature on Easy Start will help your contractor technicians as well, because if they have problems installing it, the Bluetooth allows you to upload the critical data that the Easy Start has accumulated thus far, including faults and all that learning data. It allows them to upload that to Microware, and then it can be presented in front of one of the support technicians for them to see what's going on, send you back an email or call your phone number, depending on which, if you put that information in when you upload it, and help you out. So the Bluetooth has allowed us to put Easy Start into the hands of more people than ever before. So that's a really nice feature. It also shows the live data, so if the customer wants to go in and see what the last start peak was or what the running amps are, things of that sort. Here is an example of the screens that it has. It has 6 screens. And so there's a connection screen and a live data screen. There is a screen where you can reinitiate that learning process. So let's say the learning process has an issue based on what the technicians spotted when you uploaded the data. You can actually reinitiate that learning process through the app. Before we had Bluetooth, you had to take the cover off of the Easy Start and move a jumper around. It was horrible. And then people wouldn't put the cover back on right, and it would leak water, and bad things would happen, of course. So that's another one of the big features there as far as adjustments. The diagnostic screen, where I just described where you can upload the data to Microware so someone can put eyes on it there, is the 4th screen. Super powerful. I mean, it's just that right there was made the Bluetooth all worthwhile. The 5th screen in the app is where we have the ability to turn off faults selectively. We tell people don't do that unless you're being advised to do so by the technician. This allows us to perhaps troubleshoot a little more deeply if we weren't sure what was going on. And then last but not least, Mateo is not perfect. And so I may introduce a bug in the firmware inadvertently. The Bluetooth app does allow you to update the firmware over the air in the field. So if there were ever something that we found that we could do better with Easy Start, now the Bluetooth allows you to download and update the firmware over the air and enjoy that benefit of whatever that change was. So this Bluetooth feature, come on, as I said in the video, in the installation video, no other soft starter in the world has this, and I can say that without a doubt. So it's quite powerful, and now for someone who's not too sure about what they're doing, now you've got help. You've got the whole support team at your disposal. If you've got this, you've got a smartphone, you can upload the information and we can tell you what's going on. So it's a very, very powerful feature. The Bluetooth, and all of the home models, which are UL approved, have Bluetooth. The only models that don't have Bluetooth are the lower cost RV models that we currently still sell, but those are eventually going to get switched over to be Bluetooth as well. So great stuff, and I think it, I don't know, do you think this is something that the contracting technicians would enjoy, the ability to be able to diagnose what's going on and get help if necessary?
Oh yeah, for sure. Especially when you have a product that's different. You put it in the hands of, your rank and file techs. For example, just making that, disconnecting that run winding and connecting it. That's one where you see they might get a little confused. Yes. Can help with that. And then, if there's any question about whether it's doing what it's supposed to do, it helps confirm that. But also, I just love the fact that you can go in and see live data. You can actually look at what your last start peak was. That's pretty cool.
Yes.
And I can see that being really valuable. Again, you have different types of clients, right? And this is where this product is you're going to use it in different ways for different types of clients. You have one type of client that is on solar or does have a generator. And in those cases, this is just an absolute no-brainer. Like if you have traditional single-phase, non-inverter-driven equipment that's that's in a home that has solar or generator power, I mean, this is just what you have to have. It makes total sense. And that's true whether that generator power is backup or continuous state, because in a lot of cases, it wasn't a lot of thought put into that initial inrush. It's just a really smart thing to put in to your equipment if that's the case. And we have these entire retirement communities that have all these backup generators and all this. It just makes great sense in those applications. And so let's say that they are having some sort of issue when they are on generator power, being able to go up and just see, okay, well, here's what's going on. Or if they switch to solar, you can see what's going on with it. That makes perfect sense. But then we have our regular clients, and this is where I think, I really want to think about this even for Kalos. We have this disadvantage in the marketplace, and the disadvantage is that we don't sell upgrades that aren't useful to our clients. And so things like hard start kits that a lot of people have traditionally sold as an upsell, I can't sell them because I know it's not a great idea.
You don't believe in them.
Right. I know it's not a great idea in most cases. So, but when you have a product that you do believe in, and now you can get some live data, you can show it to the client. You can say, okay, here's what it's doing. You can see now that is really, really valuable. And that's exactly what you would do, especially because it's not going to be doing air quotes here, it's not going to be a cheap upgrade for a client. But a lot of people were really excited about upgrading their homes. And this is, I know, even in doing this, I know I'm going to get some of the comments, some of the pushback will say, well, hey, look, is it worth it? Well, the client decides if it's worth it. If something is good for the equipment, and this is, then the client decides whether or not they want to make the investment or not. It's up to us to communicate it, but then when you do the installation and now when you're done, you can show, oh, here, you can see your start current is really low. This is what it would have been, or this is what the data tag rating is even on InRush, and you can compare those two, or locked rotor. That's just a really nice kind of additional benefit that you can show the client, because we also know it has all these other little benefits, like we said, protecting the compressor, all these little things that the customer's never really going to see. This gives us the ability to sort of visually demonstrate the value.
Yes, and I do actually have something to show you how Easy Start could in fact pay for itself. So we'll talk about that in a minute.
Okay.
But one more point about this. It is a gadget in terms of the Bluetooth feature is kind of a sophisticated feature. It's really, as you can see, designed to be more a diagnostic tool for a technical person as opposed to a show-off tool for somebody who may not be interested in any of what this is going on. More, as you said, your your customers who really don't want to know anything about what their air conditioner is other than the fact that it's working, this may be not very meaningful to them. But for the service technicians and the contractors who make up your listening audience, this feature is huge because now they'll be able to really take advantage. But the world is modern, the world has changed and always will continue to change. We have a lot of people who just love this app to death because they're so tied to their smartphone. They want to expand its use and everything possible. So they look at the information too. So to that point that I made up earlier, I made this chart for Easy Start and for generator sizes, both with and without Easy Start. And I did this because we did some home shows over the past couple years, and we did actually exhibit at the ASHRAE AHR Expo in Las Vegas, the big granddaddy of them all air conditioning trade show that goes on typically in Chicago, but it was in Vegas in 2021, and Microair did have a booth there. So I made this chart that shows you what you would typically need as a function for a generator as a function of air conditioning size, up through 1.5 all the way up to 6 ton, without Easy Start and with Easy Start. And I looked up the specs for a lot of units to come up with the running amps and the starting amps. So those are averages. And then I throw in the fan. And then so there's a running watts number that I show there that on average, let's pick on the 3-ton model since it's right in the middle. So your average 3-ton, once it's up and running, is drawing somewhere in the 4,500 watt range. But when it starts without Easy Start, it needs 80 amps. Now, generators, as we all well know, are sized with running watts and a starting watt specification. Typically, that starting watt specification is 20 to 50% higher. More often, they don't advertise much more than, let's say, 25% higher. I have found, and we have found at Microair, most generators can tolerate up to about a 50% increase momentarily, and they survive it. So based upon that number, I used 40% in this case. I came up with a generator size that you would need to start and run a 3-ton compressor without Easy Start and one with Easy Start. And of course, the with Easy Start uses the starting amps reduced by the 70% savings that Easy Start provides to you, the 70% starting amp reduction. And so in the case of the 3-ton, we're talking about a 12 kW generator you would need to start and run that unit reliably without Easy Start. Whereas with Easy Start, you really could get away with almost a 5 kW. Right there, the cost difference between those two generators would pay for the Easy Start. And so if you don't already own a generator and your customers are, you're looking for that upsell, as you talked about earlier, if they're looking to buy a generator, you can say, hey, if you get a generator, if you buy an Easy Start from my company and I install it, now you won't need to oversize your generator nearly as much. And that right there is a huge win, and the Easy Start can pretty much pay for itself as a result. So I feel that's a pretty important value. And then for those who already have their generator, let's say they've got one of those permanent standby generators that switches over and with a transfer switch when power goes out and runs on propane or natural gas or something like that. For those customers now, when they're on generator power, if they have Easy Start installed, they won't have to power manage quite as strictly. So now they won't have to worry about what's already running in the house when the air conditioner cycles on and cycles off, if they have Easy Start. Whereas without Easy Start, they'd have to be much, much more careful about what sort of load is already being drawn on the generator when the air conditioner wants to start. So there is some economics for you, and it's a pretty, in my opinion, I think it's a very valuable and pretty easy upsell.
Yeah, for sure. And especially for contractors who do generators, which there are a lot of HVAC contractors who do, that makes a lot of sense. But even for the technician who, let's face it, there are a lot of techs out there, a lot of contractors who are looking for things they can offer to their clients. That's just the reality. You want to increase your average ticket. There's nothing wrong with that so long as you do it ethically. And if you go up to a customer's house and they already have a standby generator in place, that gives you the ability to have that conversation. It may be, in some cases, that conversation may be a little tricky to have. It may be something you just put on a menu of different options that the customer can get. But when they have a generator, you can say, oh, okay, I see you have a standby generator. I'm going to take a look at your equipment and see if it has, soft starting capabilities. And if it doesn't, would you like to hear about how we can actually optimize your generator so that it works better on startup? And I think most clients would be like, sure, yeah, I'd be interested in that. And then you look at it, and you come back, yeah, it turns out you don't have that in place. And so here's, this is an additional benefit along with all these other benefits that it provides. So I do see it as being a nice option. And I just go back to what so many techs focus on. They don't like to offer things that feel, again, air quotes, expensive compared to the things that they've been offering. But that always frustrates me because it really should be about efficacy. Is it effective? And so if we offer things to clients that are effective and that are of value, then the client can decide whether or not they want to make that decision or not. They want to make that investment in their home. And what we find time and time again is using the language of upgrading your home. This is an upgrade to your home, and it is. This is an upgrade to your system, and it is. Let them decide if it's worth it or it isn't worth it. There's nothing, and I love the ethics of the thing. Offering something that is, it does offer a benefit versus something that potentially could actually be a detriment. And that's true of hard starts. That's true of many IAQ products that people try to sell. That's true of a lot of things that people want to bolt on. Whereas with something like this, it's got this one side, which is the generator side, which is a huge market, kind of opens up that conversation. The solar side, which is growing significantly, opens up that conversation. But then we also have just clients who want to upgrade, and it is an upgrade. And
don't forget the compressor protection on utility power. That and extending the life of the air conditioner. So to add on top of that, I always go back to that after having the conversation. But perfect. No, I'm happy to hear that, and I figured your audience would appreciate that as far as efficacy is key. It's a valid and a very legitimate and a very worthwhile upgrade, and let the customers decide. Now they'll have the information that they can and the knowledge to be able to present it and talk about all the benefits. I have one last little slide here that we can just digress into any conversation you'd like at this moment, but I wanted to put out there, and maybe you can put this in the description box or somewhere so that your podcast listeners can grab some of these links. But the right now, Easy Start is not sold through any large national distributors. We did have some serious conversations with a few of them during that ASHRAE show, but Micro-Air is a small company, has been a small company, and we like selling direct to contractors and to end users. So we have a whole bunch of individual contractors. So you can buy direct. And if you would like, if you one of your contractor listeners would like to find out about how they could become a dealer, just contact Micro-Air directly at the email I have listed here, sales@microair.net. You and I can buy one, anyone can buy one. So that's kind of how it works right now. Yeah, it's definitely best. It's still great because it is a contractor, especially for residential AC. It's a product that's going to be a contractor installed device for a lot of reasons, and one is you're interrupting the run winding, right? I mean, you're actually or the run circuit. That's something that making that connection properly is actually pretty important. So there's some things there that definitely are an advantage to a contractor. And that's where developing that relationship with Micro-Air is going to help that all make sense. And also, this is kind of what I like about it is that it's not a difficult product to install, but it's also not something that's going to take 5 seconds. And with a client, because there's going to be that kind of test startup, you're going to be able to connect to Bluetooth, you're going to be able to look at the measurements. You probably easily do all this in a half an hour, which is kind of a nice sweet spot anyway. For all of this, it's a nice sweet spot where you're there long enough that the client can see the benefit. It's something that they can actually see,
And then it has some demonstrated advantages that can be discussed with the client, where we can talk about, now we can see that starting current is lower, which is what we were looking for. And so it's got a lot of those things that we can see as a benefit. And then it's got the real no-brainer use cases. It's got the solar use case. It's got the generator use case. So I think that's great. It's interesting because this is a product that I've been looking at for years, and it's just one of those things. And like you mentioned, because it's not on the shelf at your local distributor, so it's not something that's kind of right on the front of the top of the mind. But as you start to understand more and more about how capacitors work, specifically how hard starts work, and a lot of the problems we're trying to solve with equipment, single phase PSC motor, CSCR motor type equipment, you quickly get that this is exactly the solution to so many of these problems. I do want to ask the question because I know a lot of contractors will ask it. They'll say some version of, well, look, if this is so great, why don't the OEMs put it in their equipment in the first place? And I mean, I think I know the answer to that, but I want to put that out to you.
No, it's a very common question, and I'm glad you asked. The short answer when it comes to home systems is cost and perceived value. The OEMs do not see the value of this as clearly as they should. The homeowners are now seeing it to the tune of tens of thousands of units that have been sold, obviously. And they get it, and they see where the value is. When it comes to OEM relationships, trust me, we've talked with them all. And I have more stories in the RV world than I do in the home market because there are less manufacturers and there were some specific reasons why they didn't install it there. But in the home market, these manufacturers, be them, I could drop names, but I won't. They're all in fierce price wars with each other, right? They're all in fierce competitive wars. And any feature like this that they add, even at an OEM discount, will add cost. And they aren't sure, because they don't understand it thoroughly, that the value of this addition is going to be worth it to their customer or their contractor who's going to buy the unit. So therein lies the problem. Was that the answer you were expecting?
Yeah, exactly. And I think because there's a lot of things a lot of questions we ask, like, why don't we install better run capacitors in these new pieces of equipment so they don't fail all the time? Why do we have this issue with X13 motors modules when they first came out? And a lot of the answers to these questions is just cost. Yeah, you're just trying to drive cost down, and that's not anyone's fault. It's just the nature of the market.
No.
But as a contractor, we can interrupt that process. We can stand in between and say, hey, look, where there's a deficiency in the equipment that we're selling, we can offer that. And there's so many advantages. We talk about this all the time with contractors. And these are ethical contractors who are not out there just trying to squeeze money out of their clients. There are so many advantages to offering these sorts of upgrades because then even if the customer declines it, now they take responsibility for their own piece of equipment so that when something does occur years down the road, they know that they declined this thing that would have prevented that problem in many cases. And that's a really good idea. So if you are still selling, I would even say if you're still out there selling single phase, standard obviously this isn't, you're not going to put this on an inverter driven piece of equipment, but your standard, the bulk of the equipment that's out there in the market, this is a great upgrade that should be offered to clients because if they decline it, in many cases they will. You talk about the benefits, you list the benefits, they decline it. Well, then, 10 years down the road when the compressor does fail, it was declined, right? This is an option that was declined. And we see this all the time with things like, for example, the ICM 493 that we use in order to protect from surges and brownout conditions. That's a product that we currently use a lot, especially over voltage because it's actually like a voltage monitor. We offer that to our clients because we have so many issues with power in Florida. This does a very similar thing, plus some other things, and it just makes sense to offer.
Yes, absolutely. No, totally agree. And this product will provides all of those benefits and leave it up to the customer whether or not they want to choose it in the end. One quick story, though, about another OEM application where another reason why manufacturers don't want to put Easy Start in is where the unit is made. Micro-Air is made in the United States. A lot of air conditioned air systems are not made in the United States. and we all know what country that typically is. That country, unfortunately, will never in 100,000 years import an American-made piece of an electronics. So that's one of the reasons we got ruled out of a lot of the half of the RV air conditioning manufacturing market, is because of the overseas manufacturer of the unit. And then the other manufacturer in RV said, well, I can't put it in because I'm in a fierce price war with the guy who builds this stuff in China. So that was his excuse. But so yeah, that's part of it as well. So Easy Start, made in the USA, and I'll be honest, we've really enjoyed, and the company has really enjoyed doing this in the aftermarket primarily and solely in many cases. We have OEM customers who buy it for specific things like certain pump applications or certain small special application air conditioners. But for the mainstay of marine, RV, and residential and commercial, it's all aftermarket. And we're very happy with that. I mean, it's nice because you can give the attention where it's needed, and like you said, you present the benefits, the customer either says, yes, I want it, or no, they don't, and maybe 9 out of 10 don't bite, but 1 out of 10 will, and you'll be surprised, and it's growing in popularity. And if you educate your customer, and they know about it, maybe down the road they end up getting a generator, let's say, and they say, I remember my AC contractor told me about this soft start device. Maybe I should consider that again. So we find that a lot when people get educated, let's say at a home show, and I get their information. I've had people call me up like a year later and say, hey, I saw you back then. And of course, I don't remember them, but they remembered me. And they said, hey, we're interested in that now because of reason X, Y, and Z. So last couple technical things here on this summary slide, and then I'll be done, is just the over the years I have made, and the team in New Jersey, we have made hundreds and hundreds, probably thousands, of wiring diagrams for all kinds of different equipment, where we take the wiring diagram that's on the inside cover of the unit, have the installer take a picture, send it to us, draw in where the Easy Start wire is, and send it back to them. We saved all those, and we put them in what we call the Easy Start Knowledge Bank. So you might get lucky and find your particular brand air conditioner with a wiring diagram for Easy Start already set to go. So there's that link that I provided there, the Easy Start Knowledge Bank. And then last but not least, so that you can see Matteo's poor acting skills and his poor video editing skills, the Easy Start home installation video that I did this past May, a couple months ago, is on YouTube, and it goes through all of this, including all of the wiring steps one by one. So if you want to take a look at that to get a little brief, it's 23 minutes long, you'll be locked and loaded and ready to go.
Awesome, yeah. And so all those links will be in the description, and then also just to call out a couple of the easy ones. To find out more, go to microair.net, or if you're interested in actually buying the product, you can email sales@microair.net. Matteo, thank you so much for taking the time to do this. It's greatly appreciated, and I'm excited to see what the future holds.
Great, Brian. Thank you as well. It was my pleasure. Great to be here, and hopefully your audience really appreciates it as well, and all
Absolutely.
the best.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.